You can see in this image at least 3 seminiferous tubules, sectioned with interstitial space in between. This is where Leydig cells or interstitial cells of the testis will be located, but they're difficult to see in hematoxylin and niacin sections such as this one. The clear regions are areas of artefact due to tissue shrinkage. Look at all these cells of the seminiferous tubule. They display an amazing array of different appearances of their nuclei, which is the morphological basis for us being able to distinguish each stage of spermatogenesis. First, identify Sertoli cells. You can recognise them by their relative pale staining, large, irregular shaped nuclei, although many are pyramidal, and prominent nucleoli. They tend to lie against the wall, the outer wall of the seminiferous tubule. Their lateral boundaries will be difficult to trace because their cytoplasm actually envelops all the neighbouring developing spermatogenic cells. Now let's look at the spermatogenic cells. Spermatogonia may or may not be abundant in any particular region of the epithelium. They always lie on the basement membrane and are often very flattened cells. I can't see any in this particular image. The primary spermatocytes are easy to recognise because of their large size, or more accurately, the large size of their nuclei. It's difficult to discern their cytoplasm, which blends in with that of the surrounding Sertoli cells. You can actually see individual chromosomes as they condense in their nuclei. Look here and here. Secondary spermatocytes have half the volume of primary spermatocytes. They divide soon after being formed. Therefore, you rarely see them at this stage. The best place to look, of course, would be in a region like here that contains primary spermatocytes in division. The cytoplasm becomes very eosinophilic during meiotic division, and the chromosomes cluster into a dense, irregular clump. They may be in either the first or the second division of meiosis. The metaphase plate looks like a black irregular blob within the cell. Here's one over here. Now, spermatids show an amazing range of appearances as they differentiate, going from what would look like normal, albeit small cells, which are the early spermatids, and you can see clusters here adjacent to these 3 Sertoli cells, to structures that look like mature sperm or late spermatids. All of this occurs without further cell division. Even the most mature-looking cell should be called spermatid. They don't become spermatozoa or sperm until they're released from the epithelium. Until released, spermatids have an intimate relationship with Sertoli cells, anatomically and physiologically. As expected, the spermatids would populate the uppermost layers of the seminiferous epithelium, near the lumens. Maturing spermatids are embedded within the apical ends of the Sertoli cell. As I said earlier, interstitial cells of Leydig, the endocrine hormone secreting component of the testis, are not easy to find because they're very scarce and are jammed together between the tubules. They do show up a little bit better in the next section.